Hello, everybody, and welcome back to Cryptic Humility. I am here with our guest speaker,
Taki.
Taki. Thank you for coming on to the podcast. We're very excited to have you. I say that about all my guests, but honestly, truly, I'm very excited to talk to you today. Taki has experience in smart contract programming and coding and all these various things that are very new to me in crypto. So I thought it would be super beneficial to bring Taki on to kind of share what he does, what he's been doing in the industry, kind of how he got into crypto, and just like hearing from him if you are a beginner in the market and you want to learn these topics. And honestly, I'm going to be learning a little bit with you. So without further ado, Taki, I'm going to give it to you. Feel free to explain your background and how you kind of ended up in the crypto space.
So thank you so much, Vanessa. So I originally went to school for finance and computer science. I attended the University of Oregon School of Business, and I want to pursue a graduate degree in quantum science and technology and eventually integrate it into my research and my work. But when I was in school, I wanted to work for a traditional finance institution, something like a hedge fund or an investment bank. But I soon realized that I did not want to do so. So I began researching cryptocurrency because I realized it was the intersection of my two interests, finance and computer science. And so I learned about Bitcoin and how it works and the consensus mechanism that it uses. And eventually I learned about Ethereum, which is similar by using blockchain technology, but it is fundamentally different because of its utility of smart contract applications, which we can discuss in more detail later. But I began building these smart contracts and participating in bug bounties and auditing competitions. And this led me to begin researching and learning and building on layer 2 networks such as Arbitrum, Optimism, Base, Polygon, and also Binance Smart Chain, and eventually Solana. And throughout my research and my experimentation, I discovered this concept of MEV, which is what I am currently working on, but I can explain that in greater detail later.
Perfect. Yeah, let's backtrack. First, I want to say that I can't see you doing anything traditional in life. I think you're very unique in a special way, and obviously crypto is very unique in a special way. So I also went down the path of doing traditional finance and then moving into crypto, but to be doing what you're doing in regards to smart contracts, it's so important to have you on the show because even I think in previous times that we've talked, you've said that a lot of this research, it was self-research, things that you've done yourself to find this information. So I'm thankful for you to come on and for us to hear your background and kind of what you're doing now. So let me help the audience and let's try to break this down. So first key term that you said that might be good to go over is bug bounty programs. So maybe to start, you can explain that briefly.
Absolutely. So there are large companies and institutions in the crypto space that host these competitions or these events where they will essentially give you a smart contract, of course, which is simply just a file written in Solidity, which is a programming language. And the contract is full of vulnerabilities, and they then offer money to participants to find these vulnerabilities and in essence audit them, remove the vulnerabilities, find a more secure way to write the contract. And it's very helpful for those who not only want to learn how to engineer smart contracts, but for people who want to be security auditors for the Web3 space.
And you also had mentioned MEV research, correct? If I'm not wrong. So maybe you can go into briefly explaining what that is for the audience too.
Absolutely. So the concept of MEV originally stood for minor extractable value. And so let's say with Bitcoin, the Bitcoin network uses what's known as miners to add blocks to this chain. These miners were able to reorder transactions by gas in order to generate the most profitable block for them. However, Ethereum, it originally used miners, which is called a proof of work consensus mechanism. And eventually it transitioned into this alternative consensus mechanism called proof of stake.
So you're saying that obviously Bitcoin uses proof of work consensus mechanism, which is essentially Bitcoin mining. I follow you there. On Ethereum, you're saying that Ethereum shuffled away from that and is now using proof of stake. So why does MEV matter in all of that?
Absolutely. So when proof of stake was implemented to Ethereum, the event was called the merge. They created this new system called proposer builder separation that now allows third parties called searchers to scan the public mempool, which is basically this digital waiting room for your transactions to be before they end up on chain. So it allows algorithms such as the ones that I use to scan this public mempool, detect large trades, and essentially implement some sort of strategy. And that's why it was changed from minor extractable value to maximum extractable value or maximal extractable value. This opened the door to a lot of searchers to then participate in MEV as opposed to just miners.
I see. Okay. And you said that you've been involved with that. Was that directly out of school or was this recently as well?
So throughout my research, I discovered the concept of MEV, and at some point, I began working with a few business partners to run and engineer and manage these MEV bots on a series of networks, including the Ethereum mainnet, a few layer 2 networks such as Base, Polygon, and also the Binance Smart Chain and Solana.
Perfect, perfect. Right. And we will have you go through a couple of those too once we dive into smart contracting. So if anybody's looking for examples, Taki's going to give all of his resources today to kind of guide us through this together. So let's switch gears from where you've been and let's talk about what you're doing now. So what are you doing now in the space and is it still relevant to smart contracting?
Yeah, that's a great question. So I manage a Solana mainnet and a Solana testnet validator, which is these validators are the proof of stake equivalent to miners. So instead of using a bunch of electricity and a powerful computer to add blocks, you instead have at least a certain amount of stake in order. So let's say on the Ethereum network, it requires 32 ETH in order to participate in validating. And I simultaneously engineer and refine these algorithms, these MEV bots on this variety of networks that I just mentioned.
Amazing. Good. Awesome. And so I let's angle it like this. I guess if somebody were trying to get involved in smart contracting, what would you say that smart contracting is for somebody that's completely new into the market?
I guess for computers, computers don't understand your code directly. When you write code, you use what's known as a compiler to basically convert that application, the code, into binary, which allows your computer to understand the code itself and execute the application. The Ethereum blockchain or the Ethereum network is essentially a very powerful computer. It's what's known as a distributed peer-to-peer network, otherwise known as the EVM, where it allows this series of thousands of computers around the world to become validators and execute this EVM. So what a smart contract is it's basically an application that gets compiled into binary and then deployed on this network, this blockchain, essentially. Some people in the audience may know what tokens are. These are essentially applications. They are smart contracts that have functions within them that allow you to buy and sell and run other functions that determine the supply and other necessary information. You can interact with these contracts, these applications, using an RPC connection, which is basically a communication protocol such as HTTPS or TCP or UDP, or sometimes these smart contracts are built with a front end user interface. Like if you interact with Uniswap or PancakeSwap or Aave, these are all essentially just smart contracts with a front end like HTML, JavaScript, CSS attached to them that allow users that don't necessarily want to use their command line or a package like Foundry to interact with them. The decentralization is just the network of computers that powers the blockchain. Smart contracts are applications compiled into binary that exist on the blockchain, this network of computers.
So more specifically, are you talking about dApps?
Correct. So dApps or dApps are just smart contracts that are usually built with front end user interfaces. Like Uniswap is a DApp. Aave's staking and lending protocol is a DApp. Like the 1-inch limit order applications are apps, dApps.
Perfect. We went over a lot of dApps on the podcast, so it should be familiar to people, but we've never really gone over smart contracts in this depth. So this is good to explain to people, especially the coding and what goes into it. So I think that that explains it pretty well to people as a start. Maybe you can break this down even further and go into the different kinds of blockchains if you want, unless you feel like you should include other things that maybe you didn't just say that you should say.
Yeah, that's a good idea. So, of course, you probably all know that Bitcoin was the first cryptocurrency, and Bitcoin is what's known as digital gold. And so it's just a store of value. And so with every crypto, there's two components. There's the native currency, And then there's the network or the blockchain. So your US dollars, your Mexican pesos, your Canadian dollars, your Japanese yen are managed by a centralized government bureau or institution. In the US, it's the Federal Reserve and the Treasury, the US Treasury. They essentially manage and keep track of who owns how much money, US dollars. This is a centralized system. So the argument is at any point they can lie and say you don't have that much money. This pseudo anonymous engineer or this group of engineers decided to create a decentralized system where instead of an institution managing who owns how much money, we're going to use this algorithm called a blockchain to constantly update the state of the network. Essentially, who owns how much money is what I mean by the state. So each block is just a distributed ledger full of transactions. Like I sent Vanessa money, Vanessa sent Josh money, Josh sent Jacob money. And while Bitcoin was revolutionary, it came with limitations. The first being that it has no utility besides being a store of value. And two, it used this proof of network system that is very computationally and electrically expensive, which is not great for the environment. And so this gentleman, years afterwards, named Vitalik Buterin, decided this technology is incredible, but why don't we use this network that is managing the state of the currency, thus inventing smart contract technology. So now Ethereum, it's similarly a currency. Ether is the currency, and a blockchain, which basically updates who owns how much ether. This blockchain is also a network of computers, but it has this virtual machine, the EVM, that allows you to access and interact with smart contracts. Of course, let's say if I was to build a smart contract, compile it into binary, and then deploy it on the blockchain, this allows other people to interact with my application, given that they have the smart contract address and the ABI, which is low-level technical stuff, but it's essentially binary and information on the contract to interact with it. But this also created tokens and token vaults and ERC 721s, which are NFTs, and other applications that allow users to access and trade currencies and tokens and NFTs in a decentralized way. So Ethereum was the creator of this smart contract technology, but it also had limitations, which led people to build what we call layer 2 networks. So like Polygon or Arbitrum or Optimism, which use these two systems, either optimistic rollups or ZK rollups, that basically create a blockchain on the Ethereum blockchain, or a layer 1 blockchain. And then came Binance Smart Chain, or BNB or BSC, which is a layer 1 network, but it is what we call EVM compatible. So my smart contract written in Solidity can be compiled the same way and then deployed on a different network, the Binance Smart Chain. And then, of course, there's Solana. This is pretty much my expertise. I know there's many others, but Solana is similar to where it's a proof of stake network, but there are massive differences in terms of how failed transactions are, the staking system where you don't need 32 Ethereum to become a validator, but you need enough SOL in order to participate in voting for block validity. So basically the mining or validating process, and it's significantly faster. There's a term in the blockchain world, there's two called block time and transactions per second. And so Solana is significantly faster, but a lot of the transactions on the Sol network fail, which leads to high network congestion.
Right. And we've talked about that a couple of times on the podcast too. So I'm glad that you're explaining this over again from your own perspective too, because then people get to see a deeper layer of why things evolve the way that they do on the blockchain. But so far, I'm following you and what you explained is good. Do you have anything to say in regards to the process of creating smart contracts, like maybe some of your mistakes, or maybe the first steps people should take? Like, for example, maybe the first step is that they need to learn Solidity, they need to understand Solidity and how it works, and maybe you can give some resources to that, or just anything you think to help people understand how you do your job. What are the steps of doing your job?
Yeah, absolutely. So, of course, I will provide an abundance of resources because, like Vanessa said, I did not learn this in school, even though I studied finance and computer science. It teaches you a lot of fundamental information, which is valuable, of course. Knowledge is knowledge, but everything crypto related was done on my own behalf, the research and development. The steps that I would take if I had to start from the beginning are first, learning finance and computer science fundamentals and best practices. So things like supply and demand and tokenomics and economics and what is a programming language? How does programming work? What is an IDE? Basically, the application that allows you to run your code. How to use a command line interface, like your terminal or your PowerShell. Things that are basically necessities in order to participating in the ecosystem. The second is coding basics. So I think we've mentioned this before, but your contract is written in a couple languages like Viper or Clarity, but the most ubiquitous is Solidity. But in order to interact with smart contracts or any decentralized applications, you can use almost any programming language. The most commons are Python, TypeScript, or JavaScript, Rust, and Go. And I know there's a few others, but learning coding basics using these languages is very important because, of course, coding is very mathematical. It's very quantitative, but another extremely important part of learning how to code is understanding the syntax of the programming language. And when I say syntax, it's basically the rules that govern your programming languages, like how to create a function, how to create an object, how to create a struct, how to create a for loop, a conditional statement. This is a good next step. Mastering a programming language, of course, it's helpful to master a programming language that can interact with smart contracts, but I'm assuming they all can at this point because they use these libraries and these SDKs that are pretty much engineered on every programming language at this point. The third step is research and experimentation. There are infinite resources on the internet that will give you more than enough knowledge to grow. Simply reading docs like Solidity documentation, Foundry documentation, the Ethereum documentation, like the Ethereum white paper, YouTube videos. There are courses online, like a lot of free courses. I've never paid for a single course. And start building smart contracts. There is an IDE, like one of those applications that allow you to build code. There is one called Remix that makes a little user interface for your smart contract while you're building it. And I'm sure if you look up smart contract development course or anything along those lines, almost every single one of them will use Remix to help you start off because it creates buttons and little segments to show you what your smart contract actually does. Keep building. Keep building, keep building, keep building, keep building. And once you feel very comfortable and you've experimented enough, I would suggest participating in these auditing competitions that I mentioned earlier, because not only will you strengthen your Solidity skills and your security skills, because I'm sure you all know that a lot of these smart contracts that end up on the network and used in these decentralized applications have vulnerabilities, and that's how they end up losing millions of dollars. That's why security is, if not the most important, one of the most important components of smart contract engineering. Not only will it improve those skills, but it'll allow you to network with people in the space and companies and auditing companies. And this is one thing a lot of people on LinkedIn ask me, how did I get a job, or how did I get to where I'm at in the space? And it's a knowledge-driven mindset. I remember when I started, I was like, oh, I'm going to get a job extremely easily. Like, this is a highly demanded space. It's growing. It's new, right? So like traditional finance has been around for decades, not centuries. So there are extremely knowledgeable people, but with crypto, it's a new space. It gives you time to advance. It's not that easy. These Web3 companies, these decentralized applications, the auditing companies, they're not looking for junior developers. They're not looking for someone that they can teach. They're looking for someone who has consumed so much time researching and understanding and chasing knowledge to where they have this insurmountable information base in their head. And I think if you go into the space thinking that it's like an easy, quick job to get, it wasn't from my experience. You definitely need to learn a lot.
I totally don't think it's easy at all. Just with you explaining everything that you did. By the way, thank you for doing that, because I know for sure it's going to help somebody out here not only just learn about the space, but learn it correctly, because we're facing so many scammers and fraud and illegitimacies. So it's nice to hear from somebody who not only has been through it for an X amount of years, but also has probably made mistakes through it, trial and errors, and can actually help you take the best route. So yeah, and actually on that note, like, were there any mistakes that you made or anything that you could say to help somebody even further? Like, what mistakes did you make starting out here?
So I want to go back to what you said about scammers. Unfortunately, the majority of the space is scammers and frauds. And so they'll use malicious tactics like sending you a link on LinkedIn or texting your phone or reaching out to you on GitHub to basically try to scam you. My greatest piece of advice is don't trust anyone that you haven't spoken to directly in a group meeting, because the majority of them are not willing to meet with you virtually because they're not integral. But in terms of mistakes, we all know that mistakes are the source of knowledge, but especially with programming, the biggest skills besides math with programming and even finance are problem solving and critical thinking. So as you progress, or even when you start, you're going to realize that all day, every single day, you're running into errors. Being able to debug these errors and problem solve is how you improve. Eventually, you will see a mistake so many times, or an error or something wrong, that you will realize, I've seen this many times before. I know the steps to take. And of course, with AI and all the resources online, problem solving and making mistakes is your best friend, because you will not enter this space or even any sort of software development and write perfect code. I can't imagine anyone with this god level skill.
Yes, yes. No, and that's very true. I mean, in everything, mistakes help you grow, especially I can't even imagine in coding. And again, that's why we had you on, is because there are people in the space like myself that have fallen to fraud just in different ways, but my goal is to try to bring people on to educate correctly, even if I myself don't have all the answers. Bringing people on that can give the answers in time and genuinely care about the space. It seems as though, of course, because you came onto the show, that you genuinely care about the space, you speak genuinely, and you've had great success. Honestly, I asked you everything that I wanted to talk about, but is there anything else that you feel like is critical for anybody to know? Because obviously you know this better than me. So do you feel like anything else should be included? And obviously, to let everybody know that I will have any like resources or direct links that you have, Taki can send them over to me and I'll make sure that they're in the bottom of the podcast episode. It should be clear the steps that you can take to start doing these things. I'll make sure that's known on the podcast as Taki's talking. I'll give you guys some visuals. You probably have already seen them if you're listening. And we will make sure that you are fully equipped. And of course, I will always bring Taki's information in, like through LinkedIn, if you're interested in conversing with him and hearing from him personally, if you are interested in doing this kind of work, which seems to be genius work, if I might say. And it's awesome, Taki, to like hang out with you and meet you and hear your experiences, because like I said, I don't think you're a typical person, and I think it takes a very unique person to go into the space and take a leap on it, since it is so new. But that is everything that you do is really honorable, and coming and taking the time to talk to us today is very helpful. Is there anything else that you feel like anybody should know out of everything that you said today? Is there anything that we're missing here for smart contracts?
So thank you, Vanessa. That's very kind of you. I wanted to mention the tech stack that I would use. So I mentioned this before, but your smart contract is written in this language called Solidity. You can then compile this contract, deploy it to the network, and anyone can theoretically interact with this contract with an RPC connection. And of course, with the resources that I'll provide, you'll learn all about this abundantly. To interact with this contract using code, you can do so using a few or a good amount of languages at this point, but I would suggest using either TypeScript or Rust. And I'm gonna put emphasis on Rust because not only is the language significantly faster and more secure, but it has a compiler, that unit that basically converts your code into binary. The compiler does a phenomenal job of helping you debug your code and finding the problems. It's very verbose and it explains things very comprehensively. So if I were to start from the beginning, I would 100% use Rust, and I would suggest Rust to anyone interested in getting in here. Not only can you use Rust to interact with an Ethereum smart contract or any layer 2 smart contract or a Binance smart chain contract, but coincidentally, the Rust or the Solana client, the client responsible for managing a Solana validator or interacting with it, is written in Rust. And amazingly, the smart contracts in Solana, otherwise known as programs, are also written in Rust. So you not only have an advantage by, okay, I now have learned an extremely fast language that can interact with my ETH smart contracts in Solidity, but I can understand the smart contracts themselves on Solana, because the Solana contracts are written in Rust, and then you can therefore interact with them using Rust. That's very advantageous. But you could use any language like TypeScript, Go, JavaScript at this point. I think even like Sharp.
So your recommendation would be to use Rust to be able to, if you wanted to navigate Ethereum in Solana, and I'm sure maybe there are even other blockchains that utilize that as well.
Absolutely.
Perfect. That is a good tip to give somebody if they're just starting out and don't want to make mistakes, or also just want to go the best route possible. You know, I think that you've given every single avenue for them, what they need to learn, you know, how they need to learn it, what are the first steps, resources. Are you like in any groups? Like, do you do any groups on X or like Discord or anything, Telegram, stuff like that?
I do not, but because of your help, I've enjoyed this role of educator, and I've presented like on a global level, but my social media presence is very weak. And so I'm trying to build my audience. So I'll provide any links or accounts with the resources that I'll send you.
Yeah, and I appreciate that. It's like, it's awesome to find somebody like you that is so knowledgeable in the market but doesn't have like a crazy social media. So, but obviously they can find you on LinkedIn and contact you directly there too. So that should be fine. And they'll have all the resources down below. And honestly, that I think is a good summary for the podcast. I want to close this out by saying thank you, Taki, so much for being on to the show. I really appreciate your time. As I've already said several times, I really appreciate all the knowledge that you give. If there's any questions, you can always comment directly below on Spotify as well, or on YouTube, and we will get back to you. And I will definitely be in touch with Taki as well. Maybe in time we can do other things together in the space, but yeah, that's about it. We will be back on Cryptic Humility next Monday, and we will see you then. Thank you, Taki.
Thank you, Vanessa. Good luck to anyone in the future.